Yeah, a week from Wednesday, a week from today. Also, there are gonna be 2 take-home problems. I'll post those, for sure by tomorrow, but hopefully by tonight. Give you plenty of time to work.
Is there a practice class available on campus as well? This one?
Yeah, I'll have to look at them though, to make sure the topics are covered appropriately. So that's another thing. You just send me an email or text, practice tests and take-home problems.
Do you like that guide, what's gonna be better, like, and that's too as well?
Yeah, I'll do the study guides.
Even for text.
Okay. There's a technique in chemistry called, and in molecular biology, called titration. Now, titration involves acid-base neutralization. A very common technique. Every class you take, chemistry class, you will have a titration lab or more. You take quantitative analysis, you'll have multiple, that's a ways off, but you'll have multiple titration labs. Like half the semester is going to be involved in different kinds of titration. So, what is titration? Um, uh, what? That's not how to spell quantity. Oops.
EITY.
This is ridiculous. This is a senior moment in front of my class. As a teacher, that's the worst thing. You're gonna have senior moments, but you have them at home, not in front of. This is ridiculous.
No, it was like.
Yeah, that's how to spell it. Okay, okay. In its most general form, titration is an analytical technique to determine an unknown quantity. Now, what we're going to use it for is we're going to determine the amount of milligrams of vitamin C in a tablet. That's lab 16. Lab 15 is you're going to standardize sodium hydroxide base, but they're the same technique with titration. Now, let me give you some examples of titration not involving acids and bases. When you go get allergy examinations, what they do is they do a test on your arms and they put a whole bunch of antigens on your arm and they look at what happens skin wise in reaction to those antigens on your skin. And the size of the redness determines whether they're going to treat it, one, and number two, how much are they going to treat it in terms of the quantity of your injections. And those are called titers, Titers. That's used frequently in diabetes medications, not medications, but determinations. They'll use titration. So it's a fairly universal technique. There's acid-base titration, which is the most common, but there are oxidation reduction titrations and all kinds of titrations. But it's all analytical though. It's to determine some quantity of a certain chemical. Like in our case, it's going to be first it's going to be sodium hydroxide, then it's going to be vitamin C. How many milligrams of vitamin C are in the tablet? It says 500. Is it really 500? Based on your analytical technique. So it's a very common technique. It's okay, so acid base titration. Usually 95% of the time it's used to determine a unknown acid concentration. So in the case of the vitamin C tablets, I'm looking at how much vitamin C is in those tablets. Okay. All right. So typically, with an acid-base titration, you have, I swear, this computer, I almost bought a new laptop last night. After the second glass of wine, I decided I should do this with no wine, make the decision. Okay. The reaction is you have an acid plus a base neutralizes to water plus the salt, which is the conjugate base. Okay, so if we know the moles of acid, and we know the moles of the base, if these are equal, we're not going to have any leftover H plus or OH minuses. You're just going to have water and a salt, sodium chloride or whatever. At this point, if we don't know the moles of acid, we can calculate it because we know the moles of base. Okay, and this point is called the endpoint. Now, at the endpoint, there's no excess H's, no excess OH's, so the pH of the endpoint is what? Neutral, when you say zero, right? Yeah, and what's the pH of neutrality? All right, keep going. You said 7. Okay, yeah, it's 7. So pH is 7. So at the end point, pH is equal to 7. Now, you can determine that two ways, a cheap way and an expensive way. Guess which is easier? The expensive way, right? we're gonna use, if you use a pH meter, it'll give you, a pH. So what you do is you mix these two together, and when the pH is at 7, you stop mixing them or adding or subtracting. And then from there, you can calculate moles of either base or acid. Okay, the cheap way is using a chemical called an indicator. The indicator says when it's pH 7. And it's called phenolphthalein. And it's the most common type of indicator used in schools. In fact, it's used in industry as well. I've been using phenolphthalein since 1964. I took chemistry in high school. It's just used all over the place. And the cool thing is, it turns, when the pH is 7, it turns pink. And it is a really coolest pink. It's not really a pink though, but it's pink, like I call it Barbie pink. But it's really cool. And so what you do is, in terms of moles here, we need to know how to calculate moles. We've been through this a zillion times. That's volume times concentration of the acid, volume times concentration of the base. Now, in the case of our lab, the concentration of the base is not known for lab 15. In lab 16, the concentration of the vitamin C is not known. So the goal in lab 15 is to determine the concentration of the sodium hydroxide. Okay, 4 variables, you need to know 3 of the variables, calculate the 4. Normally, we're calculating the concentration of the acid. So when we solve for Ca, we get volume of the base the concentration of the base over the volume of the acid. That'll equal the concentration, and that's concentration of the acid. 99% of the problems you're going to do are calculating unknown calculations of acids. So volume, we're going to be using something called a burette. And a burette is kind of a cool piece of glassware. It's this long, about that wide, and it's graduated in milliliters. I read out to 2 decimal places, milliliter wise. Okay, and then what we're doing is, so that would be how we measure the volume of the base. And we also need the concentration of the base, and that is given to you. In our case, in lab 15, we're going to actually calculate it, but normally they give you the concentration of the base. Down here is the unknown acid and a known volume. The unknown volume is given in usually milliliters. So we've got the 3 parts we need to calculate concentration of acid. We've got the volume of the base, the concentration of the base, The volume of the acid, what's left over is the concentration of the acid. Now, when you get into 1A or 2A, they might give you something that's diprotic acid instead of a monoprotic acid. So you always have to go back to the equation. What is the chemical equation of what you're working with? What is the relationship between the moles of acid, moles of base? Is it 1-to-1 or 2-to-1? Or 3-to-1? Always go back to your stoichiometry. What is the molar ratio, which is the coefficient, just like we do in stoichiometry calculations? That's why we balance equations. You always go back to that. Because I can tell you right now, if you get Stu Hayes for 1A or 2A, he's going to use multiprotic acids. You and I already had this discussion. And we both said, well, you just go back to the stoichiometry, the chemical equation, and make sure it's balanced. Boom, you're done. Now, for lab 15 and 16, we're using a monoprotic acid, which is 1-to-1. 1 mole of acid yields 1 mole of base. If we're using sulfuric acid or oxalic acid or something like that, then it's 2 moles of base equals 1 mole of acid. Okay, but for our class, it's going to be 1-to-1 because the chemical reaction balanced is coefficient is 1-to-1. Okay, so a typical problem, something like this. Okay, this is officially a typical titration problem. I have a worksheet for you to practice titration problems, by the way, in Canvas. In fact, let me verify it's in fact there by jumping over to Canvas really fast. Okay, so I've got a whole bunch of these problems for you with answers to check, so you can practice this. But okay, all right. So we've got at the end point. At the end point now, when we're talking about that means moles of acid equals moles of base, assuming it's 1-to-1 from the balanced equation. So we have concentration of that base, concentration of the excuse me. Let me back up here. We've got the volume of the base, concentration of the base, volume of the acid. So we can now calculate concentration of the acid using this guy here. Now, gosh, excuse me. So in my class, I like you to convert to liters. Because concentration is defined as moles per liter. So if we're measuring in milliliters, we convert it to liters. However, sometimes your instructors in 1A or 2A may keep everything as in milliliters and then they use millimoles. And to me, that's confusing for students. So I keep everything in liters. If it's milliliters, convert. And how many milliliters per liter? 1,000. Okay, so first thing is we've got milliliters and milliliters. Let's move those over to liters. Okay, because we need to do is the volume. Me okay. So the concentration of the acid is equal to the volume in liters times the concentration in moles per liter of the base over the volume in liters of the acid. So, yeah, on which?
Well,
I mean an ml?
no. Well, yeah, that too, but like you did CA, is that a capital A or you like?
Oh, no, not that one. But ml definitely matters. It's little m, big L. Okay, so volume is liters. Concentration is moles per liter. Okay, so the volume of the base is 23.4. In liters times concentration in moles per liter, which is 0.45 per the volume of the acid, which is going to be 25 mils. And of course, we need to convert it to liters, so everything cancels. That'll give you concentration of the acid. So you can do this a couple different ways. One way is just before you start anything, just convert the milliliters to liter. So it's automatic. So you don't have to have this conversion factor in there. The other way to do it is like this, and let me show you something. If you do it like this, the conversion factors cancel out, which simplifies it quite a bit. Either way though, works fine. Okay, so we're gonna go So the concentration of the unknown acid is 0.42. So that's the calculation part. Let me show you what actually happens when you're doing this. Step one is you fill your burette. This is going to measure how much sodium hydroxide it takes to neutralize the acid below. And it's measured in milliliters. Okay, that's step number one, fill a burette. Step number two is your acid. And you're going to add your acid with a pipette, which is graduated to be either 20 or 25. I forgot which. It's probably going to be 20 mil burette, and I have a line on it. So what you do is you get it, bring it to the line, and it'll automatically deliver 20 milliliters for you. Okay, so you put your acid in, and what's left?
Salt.
Uh,
A salt and water.
Water, and you're going to put in typically and you can put in 20, 25, or 30. The amount of water doesn't matter. It's the amount of acid and base that counts. What else is missing?
Salt.
We're going to make a salt. So we're going to go in this burette, we're going to go drip, 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 drip until we reach neutrality. That means the acid and base are going to be equalized. How do we know when we're there?
Yeah.
pH of what? 7. Now, how do we know we have pH of 7? An indicator. So we have to put in our indicator. So we have to put in ten drops of our indicator. Now, that is, you don't have to know this, but it's phenylphthalein. That's the acid base indicator. So it has no color until you reach neutrality. Then it goes pop, pink. That's when you stop. Now you know moles of acid equals moles of base, assuming it's 1-to-1. Could be 2-to-1, depending on what acid or base combination you're using. So with us, it's going to be 1-to-1. When it turns pink, barely pink. I'm talking about light, light, light pink. Stop, don't go any further. Now, the deal is, what I have you do is you stop when it's barely pink, and then look how many milliliters of base did you deliver? And then write that down. And after that, you're going to put a whole bunch of base in and watch the. Gosh, I don't sneeze much at all. I take a boatload of antihistamine, but anyway, and you're gonna zap it and see what color, how intense the color is. It's really cool. But anyway, the end point is reached when it's barely pink. I mean, barely. Now we're talking a drop plus or minus. All it takes. Very sensitive. So when you fill your burette, 0 is at top, 50 is at the bottom. So normally you don't read from the top to 0, you read 0 from the bottom, right? Except for 2 things, pipettes and burettes. Burettes you read from the top downward, because it's measuring how much volume is being delivered. So you're going to start at 0.00, use your dropper to get it exactly at 0. Then you're going to go drip, 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 till it turns light, 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 light pink. Then you're going to read how many milliliters of base you delivered down here. Now you don't have to start at 0, you can start at 1 or 2. Let's say we started at 2 milliliters rather than 0. And we go down, and it took 23 milliliters on the burette reading to neutralize the acid. We have to subtract now 2 from the 23. So I just tell everyone to start at 0 and you don't have to subtract. A lot of people like starting at 0 anyway. Like I don't care where I start because I know I just do a subtraction, but a lot of students are very particular and they want to start right at 0. Okay, so that's the procedure. Okay, you add the base and the burette. You add the acid below in a known volume. You know and you're going to be given the calculation for the concentration of the base, or you're going to calculate it in lab 15. So those are the 3 variables: concentration of the base, volume of the base, volume of the acid gives you the concentration of the acid. And that's the essence of titration. So the setup is basically the same every single time. It's this relationship here. Heck, let me that's the key relationship for titration. Okay, so if I change this a little bit, I could say something like, if the initial reading of the burette, let me show you another way to, this problem was going to come up. Okay, that would be another way this problem would be worded. So you have an initial and final reading of the burette. When you see that, subtract. If the initial reading is 0 and the final reading is 34.5, you don't have to subtract. If it's not 0, subtract.
You're subtracting 34.5 minus 23.4.
Exactly. And then can change everything to ml, or if you want to leave it in that big calculation, the conversion factors cancel out. Frequently, you'll see this written, titration problem written like this, as opposed to this. So in your burette, you fill it up and see what the reading is. If the reading is 0, that's fine. Drip, 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 drip till it turns pink and then read it. If you start at something else, you go drip, 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 read it, and then subtract off what you started with. Okay. I recommend you do some practice on the practice worksheets. Because you're going to see a pattern. Just like when we did stoichiometry, remember the pattern? Given to moles, mole ratio, convert to what are you trying to convert from moles every single time. And this pattern is going to be the same. You're going to be using this calculation here. This one here. And 99% of the time, you're calculating an unknown acid. But you can calculate an unknown sodium hydroxide as well, like lab 15. So you can calculate either one, either an unknown acid or an unknown base. Okay, are there any questions about this? It's a matter of reviewing it in the video and then practice those problems. Now the problems have got answers like normal. Okay, so we've officially finished unit 3. No more information. I'm going to talk about temperature in a minute here, which is unit 4. This tomorrow we're doing gases, and gases have temperature in it, but it's not in Celsius, it's in K, which is Kelvin, which I'm going to talk about today. All right. Let me show you what the worksheet looks like. So here, these are all hydrochloric acid and sodium hydroxide. Question here, remember there are 4 variables. And you have to have 3 of the 4 variables before you can calculate anything. Oh, and there are the answers, of course, like I always like to. Okay. In fact, okay, qualitatively, I want to know how a salt crystal dissolves, or it could be a sugar crystal in water. Okay, so let me see. Okay, I'm gonna post the study guide in a minute here. Okay, I published a study guide. And then I'll post a practice test that supports that study guide. So it's like this. Okay. Basically, it's there's nothing new. I'm just going to post everything we just covered in this class. Nothing, I'm not going to try to pull any tricks. If I was a student in my class and I started pulling tricks, I would hate that. So I don't do any trick questions at all. You may think it's a trick question, but it's not meant to be a trick question. Okay. So Aaron, you're gonna send me a text regarding practice test and take home. It's already done the study guide. Okay, so we're done with unit 3. So the first subunit in unit 4 is gases. So to understand gases, you have to understand temperature. In fact, I'm going to stop this and save out the titration video.